Okay, so good morning, everyone. So today we're going to continue the topic that we started yesterday. Yesterday we started factorization with the GCF and we started factoring special case formulas. We were only able to see this formula in here for the factorization, okay? That is the difference of squares. So we're going to continue now with the factorization using other methods, using this other method, which is the perfect squares. So for example, if I give you an exercise in which I'm asking to factor out completely, and your exercise is x squared minus 4x plus 4, this is a trinomial. So we actually have two different ways of factorization. One that we haven't seen, which is the factorization using proof and error, or the factorization for FOIL, okay? So we are going to do it right now with the special cases. So how do we know that this is the factorization of a special case? For us to be able to factorize, we need to be really careful and observe every single term. The first thing that you're going to do is grab the middle term, which is 4x, and you're going to divide that by 2. If that's possible to divide by 2, in this case, yes, you're going to get 2x. Remember, the middle term is 2ab. Since we divided by 2, this 2 is this one over here. So this that we got, this 2x, is actually a times b. This is a times b, okay? Very good. So now, after we finish doing that, dividing by 2, the middle term, we're going to try and see if the first and the last term have a square root. Okay, so we're going to find, just like we did in here, this is supposed to be a to the square, and this is supposed to be b to the square. So we're going to try and see if we have a square root. So is there a square root for x to the square? Yeah, remember what we did over here? We cancel out the square with the root and we get positive x. Actually, positive, negative. We're going to use the positive only. And in this case, we got the square root of 4. What is the square root of 4? What number multiplied by itself will give me 4?
2.
2. So according to this is a and this is b. We got in the middle a times b. If we multiply the a that I found with the b that I found, do I get this ab? Yeah, right? We do get it. Okay, so that is one way of finding it. And so we say a is x and b is 2. So yes, we got in the middle ab, which is 2x, and the 2 that we divided it. So yes, it is okay. So my final answer is going to be this formula over here. I'm going to use this formula. Okay, I'm using this formula. Let me place that one up here again. And I'm going to simplify and substitute for a and b in my parentheses, okay? That's all that I need to do. So I'm going to say parentheses instead of a, x, plus instead of b, 2. And I'm going to elevate that parenthesis to the second power. And this is the factorization of this trinomial. That is one way. There is actually one way of not doing this part of division. Let's see another method, okay? So let's see that we have, for example, 2y to the second power plus 12y plus 18. Okay, so first step of solving this, what is the first thing that I need to do when I'm solving a factorization? Try and see if I can use the GCF, okay? If I'm able to use the GCF, then I factor out first with the GCF, and then I try to use any other method. So So is there a GCF for 2y squared plus 12y plus 18? Do we have a GCF for those terms?
2.
2, very good. So we take out the 2. I'm going to move this a little bit to the top so I can write properly. So we're going to take out the 2 and we're going to divide. 2y squared divided by 2. Two y squared divided by 2. Y to the square. Plus 12y divided by 2.
6.
6
Y.
y plus 18 divided by 2.
9.
9. Okay, we still have a trinomial. We're going to see if we can factor that out. So this is supposed to be a to the square, remember? And this is supposed to be b to the square without doing the division first, okay? This is another way of doing it. And I think this is easier. So what is the square root of y to the square? What is the square root of y to the square?
Y positive.
Y positive or only y? What is the square root of 9?
3.
3.
3. Now remember, the middle term is 2ab. Always, the middle term is supposed to be 2ab. So if I multiply 2 times a times b, which is 3, because this is supposed to be 2ab, how much do I get? 2 times y times 3, how much is that?
6y.
6y. We got a mistake in here, by the way. This was supposed to be negative because you see this first sign is a minus. So this is supposed to be a minus as well. So we got a mistake in there. So over here it is 6y. Do we have a 6y in the middle term in the parentheses? Yes.
Yeah.
So it is a perfect square. So I'm going to copy the 2, that was a GCF. I open a parenthesis. This both are positive. So remember, we're using the formula a plus b. Okay, that's the formula that we're supposed to be using. A plus b to the square. That's my answer. So that's what I'm going to find out. A is y plus b is 3. And I place that to the square. And that is my final answer. Questions? Questions about this? No? Easy peasy? Okay, let's do one more. Let's try to elevate the complexity of this, okay? Let's try to make it a little bit more complex, okay? Not difficult, just complex. So let's see, we are going to have 16 k to the 4th power plus 40 k squared plus 25. Let me see. That's it. So do I have a GCF? Because that's the first thing that we need to do. Do we have a GCF that I can find in there? Is there any GCF in there? Do we have a GCF in 16k squared plus 40k squared plus 25? Is there a GCF? No, there's not, right? So no GCF, I can go ahead and see if it is a special case. Okay, so I'm just gonna skip writing the a squared and the b squared. I'm just gonna go ahead and find the square root of 16k squared, k to the 4th power, sorry. What is the square root of 16k to the 4th power?
8.
8 times 8 is not 16.
4.
4. So the square root of 16 is 4. What is the square root of k to the 4th power? Remember, when we did power of a power, we multiply. When we do a square root of an even number, we divide. So 4 divided by 2. 4 divided by 2? 2. So the square root of 16k to the 4th power is 4k squared. Okay, now the last term, what is the square root of 25?
5.
5, very good. Now the middle term is supposed to be 2ab. This is supposed to be the middle term. So multiply 2 times a, which is 4k squared, times 5, which is b, the one that we just found. So let's multiply. How much is 2 times 4?
8,
And 8 times 5?
40.
40, and I copied the k square. Do I have that in the middle? Yes. So what formula I'm using? I'm using this same formula for the factorization, a plus b and everything to the square. How do I know it is a plus b? Because both signs are positive. So my final answer is going to be parenthesis. Instead of a, I use 4k squared plus, instead of b, I use the square root of the last term and everything to the square. And that is the factorization of perfect squares. And factorization of perfect squares using a GCF before. Questions? No questions? Easy peasy breezy lemon squeezy? Okay, let's do one more exercise, okay? Let's say that we have, for example, okay, let me see. We're going to have twelve c to the 6th power d to the 4th power minus let me see, wait. Okay, give me a second. This happens when I make up the exercises. There. 12c to the 6th power d to the 4th power minus 36 c to the 3rd power d to the 2nd power f to the 4th power plus 27 d to the 8th power. I hope I have it properly. Okay, so let's see. What are we going to do? Okay, so the first thing is finding if we have a GCF. Is there any GCF that we can find in there? Always try GCF first. If possible, then find GCF. If not, then you can go ahead and find the special case formulas. Is there any GCF that we can find in there? Yes, Adam, 3, very good. So the GCF is 3. Now, any variable that's repeated in every single term? This is supposed to be an F. Okay, there, that's an F. Is there any variable that will be part of my GCF? No, right? There's no variable that will be part of the GCF. So I just go ahead and divide. 12 divided by 3,
4.
Or
4.
4, and I copy my variables because no variable was part of the GCF. Minus 36 divided by 3,
12.
12. And I copy my variables just as they are because none of them has GCF. And 27 divided by 3,
9.
9.
9, and I copy my variable just as it is. Now I'm going to find and see, since it is a trinomial, not a binomial, I can go ahead and see if I have a perfect square. This is negative, this is positive, so according to that, I'm supposed to use, if it's possible, the difference of a perfect square, a minus b, and everything to the square, if possible. Now, what is the square root of 4c to the 6th power d to the 4th power? Let's go with the number. Square root of 4,
2.
2.
square root of c to the 6th power. Since this
C
is
to the cube.
c to the cube, very good. You divide by 2 because it is a square root. And d to the
Square.
square, very good. So that is a. That is supposed to be a. Now let's find the square root of 9f to the 8th power. That would be b. Okay, so what is the square root of 9?
3.
3.
What is the square root of f to the 8th power?
F.
4th power.
4th
F
power.
to the 4th power, very good. This middle term should be 2 times a times b. So 2 times 2c cubed d squared times 3f to the 4th power. 2 times 2,
4.
4.
4 times 3,
12.
12, and I copy my variables in alphabetical order. So c cubed, d squared, and f to the 4th power. Do I have that in the middle term?
Yes.
Yes. So this is the formula that I'm supposed to use. So my final answer is going to be a, which is 2c cubed d squared minus, because it was minus the first sign, so I keep the minus in the first sign, b, and b is 3f to the 4th power, and that should go to the square. But don't forget this 3, because we've had a 3 in the GCF. So I'm going to copy this 3 on the outside as part of the GCF. And that is the factorization of this trinomial. So it did increase a little bit in complexity because it had more than one variable, and each variable had an exponent. We did have to use a GCF first, but at the end, we did get the final answer. And it was not that hard, right? No. Any questions about this? Now, questions. What would have happened that instead of having here a 12, I had a 14? Okay, instead of 12, I had a 14 in there. Once I get to this point, I have to do this same procedure that I have in green. You see, this was supposed to be 2 times a times b, which is 12 c cubed d squared f to the 4th power. But I had a 14, okay? I had a 14 in there. So what should I do? Nothing. I will say that this is my final answer. It is not a perfect square because it was not 12, it was 14. So I would have said that that was my final answer, and I didn't do this because it was not possible to use a perfect square, okay? Probably, there might be another way of finding the factorization of this. Sometimes there's no other way. And that's the other factorization method that we will be seeing next week. Questions? Well, then we're going to start on to next class actually, and then finish next week. Questions about this? No questions? We're clear? Okay, so we are going to place the topic for today. And like I told you, this is factorizing or factorization, factoring, using GCF and special case formulas. Okay, that will be the topic for right now. Factoring, using special case and GCF. Questions? No questions? Okay, then this is a topic. Remember, you have to upload this exercise, and I'll be seeing you in our next class with the new method of factorization.